let's move on to question number 2. So, given to you are these three equation and the target equation. So you need to make sure that you know that this is the Hess law, and you need to use all of these equations so that you can get the target equation. So let's get started with the first one. So the first one is 2NO2 plus 2NO plus O2, you will produce 2N2O4, right? And the delta H is equivalent to negative 228.54 kilojoule. So what you're going to do with this equation is that, because you need to look which one of these actually matches the target equation. So you know that you do need this N2O4 to be at the reactant instead of at the product. So you need to switch the position of this equation. So therefore you should get 2N2O4 shall produce 2NO2 plus 2NO plus O2, whereby the delta H should be equivalent to positive. See, at first it is negative, so it turns into positive. So net positive 228.54 kilojoule. Okay, so what else do you need to do with this equation? If you refer to the target equation, you need 4N2O4. So here 2 times what equals to 4? 2 times 2. So 2 times 2, you will get 4. So you shall have 4 N2O4 will produce 4NO2 plus 4NO plus 2O2, whereby your delta H shall now be positive 457.08. Alright, so we shall look at the second equation. So you have 4NO, 2N2O, 5O2 will produce 4N2O4. So the same thing, the N2O4 should always be at the reactant instead of the product. So you need to twist the equation again. So you shall get 4 N2O4 shall produce 4NO plus 2 N2O plus 5O2, whereby your delta H, we shall get positive 488.46 kilojoule. So the third equation is 2NO plus O2 will produce N2O4. So from here, what we look at is the position of the elements are okay, so we don't need to change the position, but we do need to do something with the equation. So you just have to copy the same equation, which is 2NO plus O2 shall produce N2O4 equivalent to delta H equivalent to negative 171.34. Okay, you might ask why these two equations for the N2O4 for both we need to swap places, but this one I leave it at the product instead of moving it to the reactant. Okay, so logically, if you can see here, you already have 4 N2O4 and then you have another 4 N2O4, means that you have excess N2O4 already. So you need to have something at the product so that you can slash them out later on. So from here, what you need to do is times 4. So you shall get 8NO plus 4O2 will produce 4N2O4. Therefore, your delta H is equivalent to negative 85.36 kilojoule. Right. So what you need to do is that you need to copy back all these three equations that you have already adjust. So 1, 2, 3. You need to copy it again, and then we will continue on in looking whether or not it matches the target equation. Alright, so I've already copied all these three equations. So what we need to do is now slash out all the things that we don't want from this equation that we have done. So definitely we have excessive amount of N2O4, so one of this must go. So this one we can slash with this one, right? Okay, what else? The NO. See, we don't want the NO here, and then we have 4 NO and 4 NO. 4 plus 4 is 8, so we slash this out as well. So what else that we don't need from here is the O2. So we have 4 O2 around here, so altogether we have 7 O2. Because in the target equation, we do need the O2 to be in the target equation. We need 3 O2 altogether. So 4, we have 7, right? So we shall left with 7 minus 4. So we have another 3 O2. Okay. And then what else? We do need the N2O, we do need 4 N2O4, we already have the 3 O2, and also we do need the 4 NO2. So we have met the criteria of the target equation. Now we get 4 and 2O4 shall produce 4 NO2 plus 2 N2O plus 3 O2. Therefore, your delta H should be equivalent to the summation of everything here. You should get positive 260.18 kilojoule. So this is the final answer for this question. So altogether, if you get correctly, you should get 10 marks from this question. Okay, let's move on to question number 2b. A student reacts barium hydroxide with ammonium chloride at room temperature, and the reaction proceeds as the balance equation below. So this is the balance equation. So briefly explain on the reaction profile of this reaction and predict the final temperature of the reaction mixture. Right. So how are you going to answer this question? The first thing that you need to do is briefly explain the reaction profile. So what is the reaction profile? Is the graph that will depict this reaction that occurs. So the first thing that you need to do is that you need to decide whether this reaction is an exothermic or endothermic process. So how are you going to do so is by looking at the value of the delta H. So since your delta H is negative, so means that this is an exothermic process. So since it is an exothermic process, so the reaction profile that you need to draw is the exothermic graph. So exothermic graph should be like this, where this is reactant and this is the product, and here is the potential energy, and this one is actually rate time. Okay, what else that you need to show in this thing is that you need to show where is the delta H. So delta H is here, and here is your E. Right. So this is the first part that you need to answer. The second part of the question, you were asked to predict the final temperature of the reaction mixture. So since you have insufficient information in the question, so the question asks you just to predict what shall the temperature be. So due to this reaction is following an exothermic process because of your delta H is equivalent to negative. So the energy is released into the reaction mixture as heat. So as a result, the temperature of the reaction mixture shall be increased. Question number 3A. So you were given this table and you were asked to calculate the rate constant for this reaction. So in order for you to find the rate constant, the first thing that you need to know and you need to do is you need to write the rate law for this reaction. Since your reactant is A and B, so it means that the rate law is against A to the power of X and B to the power of Y. So I've already write this here. So before you can get the value of K, you need to know what is the value of X and what is the value of Y. So the same drill that we have done before in the exercise and also in class. So when you want to find the value of X, you need to find the value of B that is similar, so that you can slash the Y so that you can get the X, because we just need one unknown because it shall be easier for you to calculate. So I'm going to start with finding what is the value of X. So I'm going to use from this experiment. So the rate is 8 times 10 to the power of negative 3 over 4 times 10 to the power of negative 3 is equivalent to K over K. So the concentration of A is equivalent to 0.1 to the power of X, and the concentration of B is 0.050 to the power of Y, and here is 0.050 to the power of X, and your B is 0.050 to the power of Y. So you can slash this, so you shall get this one is equivalent to 2, equivalent to 2 to the power of X. So your X shall be equivalent to 1. Right. So that's done. So now we are going to move on to find what is the value of Y. So for the value of Y, is the same drill. So 1.6 times 10 to the power of negative 3 divided by 4.0 times 10 to the power of negative 3 equivalent to K over K. So the concentration of A is 0.050. This one is obviously the same because we want to slash it out. So the concentration of B is 0.1 to the power of Y times 0.050 to the power of Y. Therefore, you should get 4 equivalent to 2 to the power of Y, and Y is equivalent to 2 because you know 2 to the power of 2 equivalent to 4. Alright, so from here, you can write again the rate law. You just have to copy the same thing, the rate law here. Okay, so the rate now shall be rate is equivalent to K times A to the power of 1 and B to the power of 2. Okay. Since we already know that rate is equivalent to K, A to the power of 1 and B to the power of 2, so we shall be able to find what is the value of K. So all you need to do is take any one of the data, so from any experiment, and then you can predict what is the K. So for me, I'm going to choose the third one. So my rate will be 1.6 times 10 to the power of negative 3 is equivalent to K, and then the concentration of A is equivalent to 0.050 to the power of 1, and the concentration of B is equivalent to 0.1 to the power of 2. So from here, you can get your K is equivalent to 1.6 times 10 to the power of negative 3 divided by 5 times 10 to the power of negative 4. So you should get your K is equivalent to 32 meters square over mole square per second. Right, so this is the final answer for your third question. Alright, we are now at our last question for test 1. So the reaction between nitrogen and hydrogen gas will produce ammonia. If the rate of formation of ammonia is 0.345, predict the rate of disappearance of hydrogen gas. So in this question, you were not given the actual chemical equation, so you need to do that beforehand before you can proceed to do the rest of the calculation. So given in the question, the reaction is between nitrogen, easy, plus hydrogen, which will produce ammonia. So what is ammonia? Ammonia is NH3. Please do not confuse and writing here NH4. That is a different thing. So we want the ammonia and H3. So the next thing you need to do is you need to balance out this equation. So if you can see here, you have N2 here, means that you have 2N. So here you only have 1N. So you need 2 times 2 over here. Since you have times 2 over here, means 2 times 3 equivalent to 6. So you only have 2 here, 2 hydrogen, so you need 2 times 3. 3 times 2 equivalent to 6. So this equation is balanced already. So the next thing that you need to do is that you need to write the rate expression. Just now we were doing rate law, now we are doing the rate expression. So the rate expression for this equation is rate is equivalent to, because this one is at the reactant, so it should be negative, delta concentration of N2 over delta T equivalent to negative 1 over 3 delta concentration of H2 over delta T equivalent to positive, because this one is already at the product, 1 over 2 delta concentration of NH3 over delta T. Alright, if you check again at the question, you were asked to calculate the rate of disappearance of hydrogen gas when the rate of formation of ammonia is such. So what you want to look at is only the second part of the equation. So you're just going to focus on this part. So we can write again 1 over 3 delta H2 over delta T is actually equivalent to 1 over 2, where you know delta and H3 over delta T is equivalent to 0.345. So 0.345. Alright, so what you need to do is you need to calculate this one first. So you should get 0.1725. Okay, the question asks you to calculate what is the value of delta H2 over delta T. So this one you bring up, so 0.1725 times 3, because this one is 1 over 3, so you should get 0.5175. Okay, and then you need to check again. This H2 is at reactant or product? It is at reactant, right? So it should be negative. So this is the final answer for the final question. This is the end of the discussion session for test 1. So I hope you can understand how you should answer all these questions, and I'll see you again next week with a new chapter. Goodbye.